In this video, I will go through section 1.3 of chapter 1 of Pure Mathematics 2, which is partial fractions. What we mean by partial fractions? For example, we've got a fraction 6x minus 2 over x minus 3 times by x plus 1. Okay, if we can split this fraction into two fractions because it's got two factors. Okay, we call those fractions partial fractions. Okay, so there are two methods which we will learn in Pure 2. Method 1 is the substitution method, and method 2 is the equating coefficients. Okay, first let's try using the substitution method to solve this. Okay, let's rewrite the question again. 6x minus 2 all over x minus 3 times by x plus 1. I can split this fraction into two fractions because it's got two factors in the denominator. So, first one would be over x minus 3, second one would be over x plus 1. So, I write down a for the first one and b for the second one, where a and b are constants to be found. Okay, so I put one more line here just to make it identity. So, because for every single value of x, for any value of x, this equation must be true. It must work for both. So this one is always equal to this one, no matter for what value of x. Okay, for this to be equal to this one, what I could say is, if I find the common denominator for this one and add these two up, I must get exactly the same thing as here. The common denominator between x minus 3 and x plus 1 is x minus 3 times by x plus 1. Okay, so I multiplied the first fraction by x plus 1. Therefore, I have to multiply a by x plus 1 plus b times by x minus 3 is identical to 6x minus 2 over x minus 3 times by x plus 1. So, clearly, for these two to be identical, we see that the denominators are the same. So, therefore, we have nothing to do with the denominator. All we need is just 6x minus 2 must be identical to a times x plus 1 plus b times x minus 3. So, therefore, 6x minus 2 must be identical to a open bracket x plus 1 plus b open bracket x minus 3. Okay, now we can apply the substitution method. What we mean by substitution method is you can substitute any value for x, okay, and these two expressions must be equal for any value of x. Why? Because they are identical in first place. So it must work for any value of x. But the easiest one is substitute the root of this bracket and this one by one. So if x is equals to minus 1, for example, what would happen? 6 times minus 1 minus 2 must be equal to a times minus 1 plus 1 add minus 1 b times minus 1 minus 3. 6 times minus 1 is minus 6, minus 2 is minus 8. Equals to minus 1 plus 1 is 0, so a times 0 is 0, and minus 4 times b is minus 4b. Therefore, b is equals to 2. So similarly, if I substitute x equal to 3, these two must be equal again. X equal to 3. I get 6 times 3 is 18. 18 minus 2 is 16. Equal, identical to. Sorry, identical as well. Okay. Or as we substitute the numbers, it must be equal actually. Okay. So 3 plus 1 is 4. 4a plus 3 minus 3 is 0 plus 0. So therefore 4a is equal to 16. Therefore a is equals to 4. Therefore 6x minus 2 all over x minus 3 times by x plus 1 is identical to 4 over x minus 3 plus 2 over x plus 1. Okay, so this one was substitution method. However, for both, so now let's go through the equating coefficients. Okay. For equating coefficients and substitution method, for both of them up to this point, they are exactly the same. Okay, so I just run this one. So for both substitution and equating, I write it down. For both substitution and equating coefficients. So this is the first step. The only difference is this point. This one was for substitution. Now for equating coefficients. So let's write down this one again. 6x minus 2 is equal to a times x add 1 plus b times x minus 3. They are identical. Okay, let's expand this side. We get 6x minus 2 must be identical to ax plus a add bx minus 3b. Let's bring all the x's together. 6x minus 2 is identical to ax and bx. They are the same thing, so I write down a plus b in the bracket times by x. Just brought both together and factorized from x plus a minus 3b. Okay, so now I move the page a little bit further. For these to be identical, this one, coefficient of x, must be equal to the coefficient of x here. And this one, which I circle it, must be equal to this one. Okay. 6x is equal to a plus b in the bracket times by x. We can cancel x from both sides. We get a plus b is equal to 6. Let's call this one equation 1. Minus 2 must be equal to a minus 3b. All the constants must be equal to each other. Okay, I just write it in more simpler way. A minus 3b is equal to minus 2. I call this one equation 2. Okay, equation 1 minus 2. So equation 1 minus equation 2. We should get a minus a is 0. B minus 3b is 4b. 6 minus 2 is 8. Therefore, b is equals to 2. So you've got the same value here for b. And substitute b equals to 2 here. You get a plus 2 is equal to 6. Therefore, a is equals to 4. Where a is equal to 4. Okay. So here is the end of the example 8. Okay. So let's move on to the next example, where there are more basically factors in the denominator. Let's move on to the next page. Example 9. Okay. Given that 6x squared plus 5x minus 2 over x times x minus 1 times by 2x plus 1 is identical to a over x plus b over x minus 1 plus c over 2x plus 1. Okay. Find the values of the constants a, b, and c. Okay. So I'm going to use the substitution method for this. Okay. So I could write it down 6x squared add 5x minus 2 all over x times x minus 1 times by 2x plus 1 is identical to, let's convert all of this into one fraction, x times x minus 1 times by 2x plus 1 is the common denominator. X been multiplied by both of these, therefore a times x minus 1 times by 2x plus 1. B has been multiplied by x and 2x plus 1, therefore b x times by 2x plus 1 plus c times by x times by x minus 1. Okay. So for these to be identical, 6x squared add 5x minus 2 must be identical to a times x minus 1, 2x plus 1 plus bx times 2x plus 1 plus cx times x minus 1. Okay, so since we're going to use the substitution method, we don't really need to expand these brackets. If we had to use equating coefficients, we really have to expand these brackets until some certain point. Okay, so the easiest number which we can substitute first, there are three factors which in fact we've got three roots as well as a result: x equal to 0, x equal to 1, and x equal to minus half. I would substitute x equal to 1 first. X equals to 1, it will give me 6 plus 5, which is 11, minus 2 is 9. Okay, 1, if I substitute 1 here, it will make all of this equal to 0, and all of this equal to 0. 2 times 1 is 2, plus 1 is 3. X is 1, 1 times 3 is 3, therefore 3b. And finally, b equal to 3 for this one. The next root is x equal to 0. So if I substitute x equal to 0, this one will be 0, this one will be 0, so this and this is 0, so what is left is minus 2 is equal to 0 minus 1 is minus 1, 2 times 0 is 0, plus 1 is 1, 1 times minus 1 is minus 1, therefore minus a is equals to minus 2, therefore a is equals to 2. And finally, let's substitute x equals to minus half. If x equal to minus half, this one will become 0, this one will become 0, and it is only this one here. So for this one, half squared is quarter, quarter times 6 is 6 over 4 or 3 over 2, plus 5 times 1 over 2, which is 5 over 2, minus 2, which should be minus 3, is equal to, so all of this is 0, and only this one is left over. Half minus 1 is minus half, minus a half times half is minus quarter, and it becomes 3 quarters. Divide both sides by 3 and multiply by 4, you get c equals to minus 4. Okay, so therefore 6x squared add 5x minus 2 all over x times x minus 1 times by 2x plus 1 is identical to 2 over x plus 3 over x minus 1 plus, or minus rather, because it is minus 4, 4 over 2x plus 1. It's up to you whether to use bracket for the factors in the denominator or not. Okay, so end up the section 1.3, and you should be able to do exercise 3D, which is page 11 from the pure